Assalamu alaikum students. In our previous video number 24, we discussed the two-way analysis of variance ANOVA part 1. Today we'll discuss two-way analysis of variance part 2 with significant interaction effect. In the previous video, the interaction effect was not significant. That is why we did not need further investigation. But today I will discuss an example in which there will be a significant interaction effect, and we will see how to investigate further. Two-way analysis of variance is basically an independent multifactorial ANOVA. Why it is multifactorial? Because there are more than one independent variables. An independent multifactorial ANOVA examines differences in mean scores from a single parametric dependent variable across two or more categorical independent variables, each represented by two or more distinct groups, which were called the levels, and each independent variable is also called a factor. When we have two independent variables, it is called a two-way ANOVA, which is actually a type of multifactorial ANOVA, as the factors are more than one. We can have a three-way ANOVA if we have three independent variables. In video 24, we did two-way ANOVA with significant main effects but having insignificant interaction effect. Let us see what happens if we have a significant interaction, how to investigate further. First thing to remember is it will be a little complex. This is the recap of two-way analysis of variance. A two-way analysis of variance is a statistical method used to analyze the influence of two categorical independent variables, which are called factors, on continuous dependent variable. It allows us to determine if there is a significant interaction between the two independent variables and how each factor independently affects the dependent variable. In other words, it helps to understand how different combinations of two factors impact the outcome. Assumptions are same as that of previous analysis of variance. Then we locate the source of interaction. If we find that we have a significant interaction, we need to explore the source of that interaction. For this, we have two things to do, or two methods we can deploy. Method number one is line graph. It can tell us something, but we would need some specific statistical analysis to determine if there is an interaction, and we see where these interactions are there. To locate those interactions, we use split file method. We have an example. The research question is, what is the impact of depression status? And it has got three levels: none, mild or severe, and gender, which has got two levels, male or female. On sleep satisfaction, does gender moderate the relationship between depression and sleep satisfaction? Let's do it by using SPSS, and I would acknowledge the source of this example is Mayer's 2013, and the data file that we are going to use in this example is also provided by Mayer's 2013, and file name is sleep satisfaction. Let's do it on SPSS. This is the file, and before we do anything, we should see the graph, line graph. Go in the graph, chart builder, okay, and then this dialog box appears, and we select line chart, and this is the group or multiple line chart. Drag it here, and now put your dependent variable on y-axis, drag this sleep and leave it here. Sleep satisfaction scores, this becomes our dependent variable on the y-axis. Take depression, which has got 3 levels, to the x-axis here, and drag gender to this set color box. Now we are all set to see the graph, what it tells us before we are going to test statistically. Press OK. Here is a graph, and you can see females are represented by green line, males are represented by blue line. On the x-axis we have depression status, depression levels, none, mild, severe, and on the y-axis we have got mean sleep satisfaction scores. And let me tell you, higher the score, poor is the sleep satisfaction. So higher scores show poor sleep satisfaction, and if we see that there is a difference in the sleep satisfaction scores and depression status for males and females. You can see both the lines have the slope, and this, for example, take males first. You can see as the line progresses, the severity of the depression is there, and you can see the sleep satisfaction levels tend to be poorer, and this is the maximum, and here it is about, say, 55, the maximum score. And for females you can see there is a very steep increase in the severe depression scores, and these depression scores lead to higher levels of sleep dissatisfaction or poor sleep. You can see that the females or the women are experiencing more sleep dissatisfaction or poor scores on sleep satisfaction when they have got severe depression status. When their depression is severe, they have got higher levels of poor sleep. It means that we can have both main effects of depression and gender. And now see, is there any interaction? This graph gives us a hint that there is possibly an interaction. How? See this, when these two lines cross each other, when these two lines are parallel, they do not touch, do not cross each other, then we can say there is no interaction. There may be main effects, but there is no interaction effect. But here we can see both the lines are crossing each other, so we can predict that there is a possibility of a particular significant interaction effect. Let us see how does our ANOVA test tell what is the situation. We go to analyze and general linear model univariate. Sleep satisfaction is to be shifted to dependent variable list. Then gender and depression, which are both categorical variables, need to be shifted to fixed factor box. And from options we go to descriptive statistics, estimates of effect size, and homogeneity of variance tests. We press OK, and then we go to post hoc test. Here you will see there in factor list we have got 2 variables, but for post hoc test you will take only that variable which has got more than 2 levels, and here we have depression status which has got none, mild, and severe, 3 levels. So we shift this to post hoc test box. We click Turkey and continue, and we press OK. Okay, from this table you can see there are 45 males, 45 females, and depression status. There are 30 who got no depression, 30 who got mild depression, and 30 who got severe depression. And if we see the statistics, descriptive statistics tell us that males have got better sleep satisfaction. You can see the mean of sleep satisfaction for males with severe depression status is 59, and with mild depression is 53, and with no depression is 47. And the score of females with severe depression is 74, and for severe depression male score is 59, and similarly for mild depression females score 58, and for no depression female score 46. It shows that the depression status among females leads to poor sleep satisfaction scores, and as I told you earlier, higher the score, poor is the sleep satisfaction. So higher the depression, higher is the sleep satisfaction score. So poor is the sleep actually. So severe depression, poor sleep for females. So it shows that females are experiencing more sleep disorders as compared to the males when they have severe depression. And Levine test shows us that its p-value is 0.42, so we can confidently say that variance of a dependent variable is evenly distributed across the groups. Now we see the main table of the ANOVA. Here the most important thing that we are looking for is gender depression status interaction. This is the gender depression status interaction, and it has F value of 3.18 and C, which is less than 0.05. So we can conclude that there is a statistically significant interaction effect. Now we look for the main effects. Depression status, it has got p-value 0.000. It means that it is also statistically significant. And the other main effect is gender. It is also p-value, it has 0.021, which is less than 0.05. So we can say that both the main effects, gender and depression status, are statistically significant. Now we see the multiple comparisons. Here you can see that none and mild groups have got statistically significant difference, because this is shown by asterisk, and none and severe have also statistically significant difference. So all the groups have got statistically significant differences. Now we have to see where the interaction is playing its part among the factors, among the categorical variables. Let us see. For this we will be going for another method which is called split file method. Now we go to data, split file, click this radio button, compare groups, and transfer gender to group based on, and OK. Now this has split our file according to the gender. Now actually we want to see that where are the differences, where are the sources of interaction in gender. Now we will run a one-way ANOVA. Take analyze, compare means, one-way ANOVA. So here we transfer sleep to dependent list and depression to factor list, and click post hoc Tucky and continue. This gives us the spread of depression according to the gender. Here first we see that in the main ANOVA table, as we have split file according to the gender, male and female, you can see now we have got two ANOVA tests, one for male, one for females, and as we have done this test for the two groups, so you must understand that you have to divide the alpha value by 2. Now our alpha value 0.05 divided by 2. Now 0.025 is our cutoff value, not 0.05, because we have divided our test into two groups. So you can see for males the value is it should be less than 0.025. For males this is insignificant. Again, it should have been less than 0.025, because doing this we get 0.025. So here our significance value, p value, will be compared against against alpha, which is 0.025. so this is insignificant. However, for females the p value is 0.000, which is less than 0.025. so we conclude that there is a significant difference regarding the females in respect of the depression. Let us see how it is different. For males it is already insignificant, so we will see for the females. None and mild are significantly different, and none and severe are also significantly different. And you can see that the depression is the sleep satisfaction of the females is poorer if they have severe depression, because this can be seen in the output. Once again, you can see we go to analyze, one way compare means, and here we have descriptive statistics. This will show us the real picture. See, these are the descriptive statistics. For males mean is 53, 59 for severe depression, whereas for females this is 74, and for females this value is also statistically significant, less than 0.025. So we conclude that the depression level do interact while predicting the sleep satisfaction levels of the females. In the first split file method, we have seen sleep satisfaction versus depression severity according to the gender. Now we'll see sleep satisfaction versus gender according to the depression severity. Now let us see how does this work. Now we go to data, split file. Now we'll use depression. File will be split according to the depression. Group based on depression. Compare groups. Now OK. And now we go to do the t-test. Analyze, compare means independent sample t-test. Here test variable is sleep satisfaction, and grouping variable is gender. Define group for 1 for male and 2 for females. Continue. Options, it is 95%, this is fine, and now OK. You will see that we have performed 1, 2, 3 additional tests, so our alpha value has to be divided by 3. In the previous example we divided alpha by 2 because there were 2 tests. Now there are 3 tests. Now let us see what happens if we divide 0.05 by 3. We get 0.016. Now cutoff value is 0.016. We can see that the independent sample t-test, depression status none, it is insignificant because p-value is more than 0.016. For mild depression it is again more than 0.016, so it is insignificant. And here you can see severe sleep satisfaction scores are significant with p-value 0.002, which is less than 0.016. So severe depression leads to poor sleep satisfaction, which is statistically significant. You can see gender differences are insignificant with none and mild level of depression, whereas gender differences are statistically significant when there is severe depression status. So we have got the results and we will report them like this. An independent two-way ANOVA indicated that there was a significant main effect for gender in respect of sleep satisfaction scores with p-value 0.021 and significant main effect for depression severity. Turkey post hoc tests on the depression severity data showed that the sleep satisfaction was poorer for those reporting severe depression compared with no or mild depression. Furthermore, sleep satisfaction scores were poorer for those reporting mild depression than for those reporting none. There was significant interaction between gender and depression severity with p-value 0.047. Statistical and graphical analysis indicated that the interaction was illustrated by sleep satisfaction only becoming significantly poorer with increasing depression severity for women, and that the sleep satisfaction scores were only poorer for women than men when they had severe depression. So I hope you would have understood this complex analysis of interaction. This is two-way analysis of variance, which is part of multifactorial analysis of variance. And you must remember that whenever there is an interaction and that interaction is statistically significant, we have to locate for the sources of the interaction, sources of the difference, and we can locate by using first a graphical method by plotting a line graph, and then we go for statistical tests. Hope you have now understood from video 24 and 25 that how two-way analysis of variance works. Thank you very much. Take care.